Welcome back to Algebra 2, Chapter 7, Section 6. In this book, we've been talking about fun, interesting math, I promise. And today we're going to talk about solving radical equations. That's just fancy math, where it's an equation and it's got a radical in it, like this one. So we're going to solve it the regular way. What's the regular way? Asking ourselves the question, why is x not alone? Well, it's got two things. It's got a -4 and a cubed root. Which one are we going to get rid of first? The one that's furthest away, which is the -4. How do we get rid of it? By doing the opposite. And the opposite of -4 is +4, and what we do to one side, we do to the other. Those cancel out. So x cubed equals 4. So why is x not alone? It's having a cubed root taken. What's the opposite? Cubing. And what we do to one side, we do to the other. So that frees it from the radical, and you just get x equals 4 cubed, which is 64. That's easy, isn't it? Let's do another one. They have 2x to the 2/3, 3/2, which you know is a radical. You can write it, you could write it 2x, 2 times the square root of x to the 3rd. Remember that 2 is on a swing, and it swings around to tell you what root to take, and it says wee, and then the 3 is the exponent. Okay, so what I did first was rewrite it. Yes, but I got, there's my 2. I left off my 2. I did it twice, is why. Alright, so I rewrote it like this, and then I said, why is x not alone? It's being multiplied by 2, and it has the square root and a 3rd power. The 2 is considered what's furthest away, so I do the opposite and divide both sides. Oh, I know what I did. Sorry. I'm jumping ahead of myself. I did this problem a minute ago. I was like, what? Why is x not alone? Just remember this. I was jumping ahead. See, I wasn't going to show you this until there, and I got ahead of myself. So let's just hold my horses, okay? So 2x to the 3/2 power. I'm going to go ahead and say why is x not alone here, and it's being multiplied by 2, so the opposite is divide by 2. What I do to one side, I do to the other. Then I get that x to the 3/2 equals 125. Then I'm going to turn that into this. I'm going to go ahead and put that 2 on the swing, put it up here, and it's x to the 3rd power. Now why is x not alone? Well, it's got a square root and a 3rd power. We get rid of the square root first. And how do we do it? By squaring. And what we do to one side, we do to the other. And it frees that x cubed down to here. And that is what 125 squared is. Now, why is x not alone? It's being cubed. What's the opposite of cubing? Cube rooting. And what I do to one side, I do to the other, which you will do on your calculator. It's under math. And then you can go down to cubed root, or you can use the xy one. And x is 25. Now the book keeps it as fractions and doesn't turn it into a radical sign. So if you want to see it stay fractions the whole time, you can look at the book. Okay, so here's one. And before we can say why is x not alone, we need to, well, we can, but the reason why it's not alone is it's got a 4, a -7, a radical, and a 2, and we're going to work from the furthest to closest. So first we're going to get rid of +2 by doing -2 to both sides. Those cancel out. And the square root of 4x -7 is 3. Now why is it not alone? Well, we need to get rid of that radical. So how we're going to do it is we're going to square both sides. So now it's free. Yay! 4x -7 equals 3 squared, which is 9. Now, why is it not alone? It's got a 7 out of 4. We're going to get rid of the 7 first by adding 7 to both sides. 9 plus 7 is 16. Why is it not alone now? It's being multiplied by 4. 16 divided by 4 is 4. I'm pretty sure you did these in Algebra 1, so that shouldn't be too hard. Now what about this one? Well, it's ugly, but how we can make it prettier is if we move this -2 times the square root of x to the other side by adding it, doing the opposite, and then we can square both sides. It frees that out of the radical. 2 squared is 4, and it frees that out of the radical. Now we can do -3x as we gather up our terms, Those cancel out. 4x minus 3x is x. Bring down what you didn't mess with, 2, and x equals 2. Now, a cautionary tale, a word of warning, a trap I have fallen in myself. It's called extraneous solutions. Let me show you what I mean. Okay, I've got x minus 4 equals square root of 2x. So I decide that I want to get rid of that radical, so I square both sides. It frees this, and I get x minus 4 squared is 2x, so I write it twice and multiply it. X times 4, negative 4 times x, negative 4 times 4, and I get this. I do some gathering up my terms. Negative 4x minus 4x is minus 8x. Now I need the 2 to move to the other side, so I do minus 2x to both sides. Those cancel out and I get 0. Why did I want it all on one side? Because of that squared, I knew I was going to have to factor it. So then I factored it, and what you can multiply to get 16, but add or subtract to get 10 is 2 and 8. 8's the bigger number. It gets the sign of the middle term. What sign does this have to have for this to be positive? It has to be negative, because 2 negatives make a positive. So x equals 2 or x equals 8. Now I put it back in to make sure I didn't generate extraneous solutions, meaning false solutions. One way to check it is to put it back into your original equation. 2 minus 4 equals 2 times 2 square rooted. No, it doesn't. 2 minus 4 is negative 2, and negative 2 is not the same as positive 2. Nope. 2 is an extraneous solution. Now we're going to check the 8. 8 minus 4 equals 2 times 8 square rooted. 4 equals 4. Yep. That one is the answer. Now you can also use your calculator to check. You put in 1/2 of the original equation for x1, x minus 4. Put the other half of the equation in for y2, square root of 2x, graph them, and then find the intersection by doing second trace intersect, and where they intersect is going to be 8. Your book shows you how to do it. Look at it, make sure you can do all of these examples. Use that calculator, come back and we'll learn some more exciting math. Math is great.